day, everyone. This is again Mr. Matthew T. Sabasales, your friendly science teacher from Zamboanga del Sur National High School. This time, I will be presenting to you another video. This is already our fourth video, and this time I'm going to discuss to you the Earth's atmosphere. In fact, if we previously look into the topics that we have already discussed, uh, maybe you can look into it as a combination of both the solid part of the earth, which is actually the lithosphere. That is why we discussed already about landforms, some other land masses, and as well as we already have discussed about the different uh, water parts of the earth. We call it the hydrosphere. So we are already done with the lithosphere and the hydrosphere. So this time, friends, I will be sharing with you about the Earth's atmosphere. So we have here the handout. I think you have the handout, so you can just get your handouts. And this is actually prepared by Miss Lindela Bay Lagdamin. So you can get your handout, and I'm going to share these things to you. So, do you have already your handouts? Thinking of the Earth's atmosphere, one thing that we can think about it could probably be directly be focused into considering the air. So something it has to do with the gases which is found in the upper portion of the Earth's crust. So the atmosphere actually is a mixture of no, in Earth it's a mixture of 78% nitrogen and 21% oxygen, and only 1% comprises other forms of gases. So which is actually presumed that the largest amount of gas that is found in our atmosphere is attributed to the presence of nitrogen gas. And of course, the very important gas that is present in our atmosphere uh, in the context of human consumption, perhaps the oxygen that is actually covering 21% of our Earth's atmosphere. So the atmosphere is divided into five layers. Later, you're going to talk about that. So here are the picture, the image showing the five major layers of the atmosphere. So if you're going to start it from the Earth's crust, you just have to measure 7 kilometers from the surface of the Earth towards the 7 kilometers up. That comprises the first layer of our atmosphere. We call that the troposphere. And from that 7 kilometer upward down to 50 kilometers approximately, this symbol over here represents approximation. So approximately 50 kilometers, that comprises the stratosphere. And the most important uh, significant part of the stratosphere is actually the ozone layer. I think you're very familiar with the ozone layer because you've been hearing about the ozone layer since I think when you were still in the elementary grades. That is why we are prevented to burn plastics. Later, I'm going to share with you why we need to keep away from burning plastics and to really preserve our ozone layer. And from that particular level, from the stratosphere in here, 50 kilometers uh, above the surface of the Earth, moving forward, upward, down to 80 to 85 kilometers, that comprises the third layer of the atmosphere, which is actually the mesosphere. The mesosphere, we are going to learn more about the mesosphere layer. But after the mesosphere, from this 85 down to 640 kilometers upward, that comprises the thermosphere or the ionosphere. So that is actually the boundaries of these two particular layers. But basically, this comprises one layer already. Then after that, outside the Earth's atmosphere, we have the exosphere. That's actually the last layer that we are going to learn about. So these are the five layers, and you know what? Because of the presence of these particular layers of the atmosphere, we experience various kinds of weather. In fact, uh, we usually are dependent on the weather that is actually exhibited by the different areas. No, I think I have already explained to you the difference between weather and climate from our previous video. And of course, another significant thing that is there in our atmosphere is actually the magnificent formations of clouds. And I think you've been watching these clouds since you were no, a little kid, and you've been imagining lots of figures on these clouds. This time, we will try to individually look into some of the features of these particular layers in the atmosphere. Let us start it with the troposphere. The troposphere is actually the first layer after the Earth's surface. And you know what? This layer contains 75% of the atmosphere's mass. So which means most of the concentration of the matter which is there in our atmosphere is actually settled on this troposphere. And that is actually around, extending above up to 10 to 15 kilometers above the Earth. And if we will try to look at the troposphere, it is seemingly wider in the equatorial region than the polar region. So, since our Earth is actually oblate spheroid in structure, so in the equatorial region, there is greater, uh, wider area in the troposphere here in the equatorial region than in the polar regions. And you know what? The temperature on the troposphere and pressure drops as you go higher up to the troposphere. So which means from the lowest level of the troposphere, temperature and pressure is greater, and as you go higher and higher in the troposphere, the temperature and pressure drops, meaning it decreases. No, temperature and pressure decreases as we go higher and higher in the troposphere. That's one major thing that we can think of. But uh, which means we actually are standing and we are actually experiencing all of this wind. We experience the air that is here in the troposphere because we are still part of the troposphere. We are already settling in the troposphere, and the gases which we inhale and exhale are actually part of the troposphere. But the upper part, the topmost portion of the troposphere is actually what we call the tropopause. What is significant of this tropopause is that it is considered as the cold trap. Let me highlight this with you. That's actually what we call the cold trap. Why it is called cold trap? Because the this tropopause, the topmost layer of the troposphere, is actually the layer wherein uh, cold or heat will never eventually move up. No, it will not anymore move. No, it is sometimes considered as the thermal layer because this is a point where rising water vapor cannot go higher. So which means if water eventually evaporate, the water vapor cannot actually extend upward than the tropopause. So that is why it is considered as the cold trap. And it is actually very significant because without this tropopause, probably water could eventually evaporate and go out into space. And because of the presence of the tropopause, this water is prevented from moving out from the earth, and we can actually recycle the water here, and we can actually reuse the water, and the water will never move out, and we can make use of it, and we actually are dependent mostly of water. So this is actually very important. That is the most important feature in the troposphere because of the tropopause. And uh, in the tropopause also, there is an even heating of the regions of the troposphere by the sun, and it causes convection currents and winds. So if you happen to ride an airplane, there is that particular portion in the tropopause wherein there is greater wind currents. So we can actually experience wind currents, and mostly some of these gliders are actually utilizing this uh, particular wind currents for their leisure. For sometimes they enjoy no, jumping into skydiving, and because of the wind currents that is there in the tropopause, they can actually experience that. Warm air from Earth's surface rises and cold air above it rushes in to replace it. When warm air reaches the tropopause, it cannot go higher as the air above it. So in the troposphere, it's warmer and lighter. So preventing much air convection beyond the tropopause. So the tropopause acts like an invisible barrier and is the reason why most clouds forms and weather phenomenon occur within the troposphere. So weather phenomenon, these phenomenons that we are actually experiencing on weather, typhoon, the clouds, the phenomenon of clouds, and some of these things we experience usually are due to the presence of this particular layer in the atmosphere. So after the tropopause, actually is what we call the stratosphere. The stratosphere is the layer lies directly above the troposphere, and it is something about 35 kilometers deep and extends from about 15 to 50 kilometers above the Earth's surface. And you know what? The stratosphere is warmer. So compared with the troposphere, which is actually the temperature and pressure drops, no, as it goes higher in the troposphere. That's the idea. So which means in this layer over here, higher temperature is in the lower portion, and in the upper portion it's very cold already. But when you go upward after the tropopause, you can experience warm layer. So it's actually warmer at the top than the bottom. So the lower portion has nearly constant temperature in height, but in the upper portion of the temperature increases with altitude. So it's actually exactly opposite. If we will try to figure that out, from here, hot to cold, it decreases, but here, cold to hot. So it seems like there is something is opposite, no, with regards to the troposphere and the stratosphere. In the stratosphere, warmer in the top and than the bottom, so the lower portion is actually seemingly cooler than the upper portion of the stratosphere. So the temperature increases with altitude is the opposite of the situation of the troposphere. And one major important structure or one major important layer found in the stratosphere is actually the very famous ozone layer. I think you're familiar with ozone layer. In fact, as what I've said, since from elementary grades, you are actually instructed by your teachers and your parents and even your uncles and aunties not to burn plastics, because if we burn plastics, eventually it will actually damage or create holes into our ozone layer. Our ozone layer actually is a certain gas which is composed of three atoms of oxygen. That is why the symbol for that is O3. That's the chemical symbol of the ozone layer, and it is lying within the stratosphere. And one of the major significant thing of this ozone layer is that this ozone layer is a protective layer, and it shields the earth from harmful ultraviolet radiation from the sun. You know what? This ultraviolet radiation is very harmful. In fact, if this directly hits your self or your internal organs, it could eventually be damaged. Some of the genes that is there in your on your nucleus in your cells would eventually be damaged, and eventually it could trigger into lots of diseases, cancer, for example, tumors. So, which means ultraviolet radiation from the sun must be prevented from directly entering our surface to prevent killing and causing diseases among our the different living things in the surface of the earth. So the ozone layer is very important. But you know what? Uh, Little by little, because of the continuous usage of no, burning of plastics by human beings, our ozone is little by little, no, being damaged and depleted, getting thinner and thinner. In fact, there is this research wherein scientists are actually thinking that as large as North America and Antarctica, no, there is already that big hole in our ozone layer. That is why we must prevent ourselves from burning these plastics. So I'm going to discuss that to you later. What are these things that is there in the plastics that could damage our ozone layer? But that is our protective layer from ultraviolet radiations, ultraviolet rays from the sun. So another thing with regards to the stratosphere, there is this layer, a level in the atmosphere, which is the boundary between two layers. We call this the stratopause. Sometimes this is also known as the mesopeak. So that stratosphere and the mesosphere are two most major layers in the atmosphere, and within that layer, there is a boundary within these two layers, is actually what we call the stratopause. So let me highlight this stratopause with you. That's the stratopause. Okay, and sometimes it is known as the mesopeak. So in this stratosphere, the temperature increases with altitude, and that is what we have learned. And the stratosphere is the region where a maximum in the temperature occur. So which means highest level of temperature is here being observed in the stratopause. So this atmospheric feature is not only associated with the Earth, it occurs on any other planet or moon and as an atmosphere as well. So the stratopause is 50 to 55 kilometers above or high above the Earth's surface, or around something 31 to 34 miles. So the atmospheric pressure is around 1,000 uh, of pressure at sea level. So the temperature of the stratopause is 15 degrees Celsius, a negative 15 degrees Celsius. We will be learning more about that. So after that, as what we have learned, the stratopause is the topmost level, the highest level of the stratosphere, and it's actually the boundary between the stratosphere and the mesosphere. So the next layer that we are going to talk about is the mesosphere. Accordingly, the mesosphere is lying around something 50 to 80 kilometers above the Earth's surface. So the mesosphere is a cold layer. If the stratosphere is seemingly a hot layer, especially in the stratopause, it's very hot on that particular layer. The mesosphere is a cold layer. So where the temperature generally decreases with increasing altitude. So which means it is again exactly opposite than the stratopause, the stratosphere. So the atmosphere is very rarefied, nevertheless thick enough to slow down meteors hurtling into the atmosphere, where they burn up, leaving fairy trails in the night sky. So the mesosphere is actually the reason why we actually observe lots of streak of light. We call this the sometimes you call it falling star, but that is actually what we call shooting star, because it's not really a star, it's actually a meteor. So it's a meteor shower, for example. So this meteor will eventually hit our Earth's atmosphere, and as it passes into the mesosphere, since it's a cold layer, because of that decreasing temperature in that particular region, and lots huge amount of gases, friction will be generated on the as the speeding meteor will eventually get inside the Earth's surface. Friction will cause heat into the meteor, and eventually it burns up, and it causes something like a streak of light. We call it meteor. And if there are lots of it, we call it meteor shower. And you sometimes call it falling star, but it's not actually a star, because star is even bigger compared to our Earth. So it is just a burning meteor, meteor, and then as it hits the surface of the Earth, if there is this something that survives, it will be called meteorite. Okay, so that's the mesosphere. And the next layer is actually what we call the thermosphere. The thermosphere extends from 80 kilometers above the Earth's surface to the outer space. So the temperature is hot and may be as high as thousands of degrees, as the few molecules that are present in the thermosphere receives extraordinarily large amount of energy from the sun. So which means this is the hottest layer in the atmosphere. However, the thermosphere would actually feel very cold to us, because of the probability that these few molecules will hit our skin and transfer energy to cause appreciable heat extremely low. So the thermosphere corresponds to the heterosphere. So a zone where there is no uniform distribution of gases. In other words, the gases are not well mixed. Instead, they are stratified, that is on layer. So in accordance with the molecular mass, in contrast to the gas in the homosphere consisting of the troposphere, the stratosphere, and the mesosphere are uniformly distributed. So in the thermosphere, the gases are not uniformly distributed, causing them irregularities of temperature gradients. So the last layer actually is what we call the exosphere, the outermost layer of the Earth's atmosphere. It starts with an altitude of 500 kilometers and goes out to 10,000 kilometers from the surface of the Earth. So within this region, particles of atmosphere can travel for hundreds of kilometers in a ballistic trajectory. When you say ballistic trajectory, it refers to something like a movement, just like a speeding bullet, something like we call that trajectory, the movement of a flying thing. No? It's actually parallel on the surface of the ground. So, in this particular exosphere, particles escape. So, if ever uh, a spaceship or a space rocket would eventually be allowed to fly out, when it reaches the exosphere, eventually that is already the last layer, and that is already something that the Earth's gravitational pull cannot anymore pull the the spacecraft or the rocket, which means if you pass by exosphere already, you have already escaped the no, you have reached escape velocity. So later on in higher grades, you will be learning about escape velocity. So that's actually the velocity that must be reached for you to be able to escape Earth, because there is this gravitational force that eventually pulls all objects downwards towards the center of the Earth. But as you hit a certain velocity which is higher than the velocity uh, that is the force exerted by the Earth's pull of gravity, eventually you will reach escape velocity and you will eventually escape Earth. So the lower boundary of the exosphere where it interacts with the thermosphere is called the thermopause. So it starts with an altitude of 250 to 500 kilometers, but its height depends on the amount of solar activity. Below the thermopause, particles of the thermospheres have atomic collisions like what you might find in a balloon, but above the thermopause, the switch over to purely ballistic collisions. So there are many collisions over there. It could be a collision of solar particles or sometimes meteors or sometimes asteroids. No? But basically, asteroid is actually bigger. Meteoroids probably. So the atmosphere as a system. So the several atmospheric phenomena that have become critical in the understanding and guardianship of our environment lies on the exosphere. So it seems like that the exosphere is very very important because it is the the outer guard of the earth from the entrance of several harmful particles from outer space. The current state of the atmosphere is the result of the multitude of facts. The energy from the sun produced the movement of currents in the atmosphere, the energy, the Earth's movement relative to the Sun, and the components of the atmosphere and the Earth's surface maintains long-term climate. So the short-term weather and the temperature conditions, this provides conditions fit for the forms of life found on Earth. So when we talk about these different layers of the atmosphere, the very reason for all of this particular arrangement of gases in our atmosphere is to support life on Earth. And it could trigger a lot of atmospheric phenomenon. So one basic phenomenon that we can think about could either be two major atmospheric phenomenon, could be physical and natural. When you say physical, so this is a natural phenomenon involving physical properties of matter and energy. So all of these gases, all of these particles in the atmosphere are actually uh, naturally physical in context because it has a physical manifestations. All of the properties exhibited by these physical elements and particles, substances, are something that performs, no, it exhibited by these particular gases. We call that physical phenomena. But we also have natural phenomena. So all phenomena that are not artificial are considered natural phenomena. So two particular atmospheric phenomena. And I would like to stress out there are many atmospheric phenomena. So let me cite to you the first atmospheric phenomena that is very common to all of us and we are very familiar with it is the presence of clouds. Clouds are actually very visible. We sometimes observe it during daytime. Different figures we can try to imagine about that these clouds, but these are actually the product of this atmospheric phenomenon. That is basically a phenomenon itself. So water or clouds are actually a mass of water or ice particles suspended at the altitude in the atmosphere, especially in the troposphere region. So packet, a local region of low pressure or descending air that causes a plane to lose height suddenly. So that's actually the formation of the clouds. And another atmospheric phenomena that I can share with you is the aurora. Although we cannot actually experience aurora in the tropical regions, aurora can only be observed in the temperate regions in the southern hemisphere and in the northern hemisphere. I will show you a video of what will take place during aurora. This is actually a video taken from Microsoft student in Carta. So let me set this up for a while so that you can observe aurora. Aurora actually is a display of different colors of light. So let us try to look at that. Aurora. There are two auroras that we can experience. The one that is there in the north and the one in the south. The one in the north we call it Aurora Borealis and the one in the south we call it Aurora Australis. So are you ready to see the video? So let me show to you the video. It's not a video. So let me have this other one. Do you see? This is the image. No? This is a certain previous footage that was taken in the southern and northern hemisphere, transmitted by the aurora that displayed that if we look upward during the night, we bright colors of light, different colors of light. That's what we call aurora. Do you know what's the reason why we have aurora? Do you want to know? It's actually a wonderful, magnificent display of light, display of different colors, green, blue, violet, yellow. Just picture us like this. There's white. It will fill the entire atmosphere as you see upward. You can observe that. You know what's the reason why we have this aurora? Aurora is actually caused by charged solar particles. As we all know, there is this phenomenon performed by our sun, which is actually uh, a tremendous burst or explosion of various charged particles. It could be negatively charged particles. Sometimes electrons could be burst into the atmosphere and because of a certain explosion. We call it solar flare and solar prominence. So this solar flare and solar prominence is something like a gigantic explosion. It seems like uh, an, if you happen to see a video about an atomic bomb, no, exploding atomic bomb, that is actually normally exhibited in the surface of the sun, and we call that solar flare. So this solar flare, when it explodes in the surface of the sun, huge amount of solar particles, we call it charged solar particles, will be spread out all over the the solar system. And you know what? When it pass by Earth, our Earth actually is having a magnetic field wherein most of these particles will be driven towards the northern and the southern part of the Earth. So we have here a globe over here, the northern part and the southern part. We have something like a barrier, wherein if particles will hit, it will be drawn towards the polar regions, the South Pole and in the North Pole. And you know what's significant of that is that when these charged solar particles hit the Earth's magnetic field, it will be brought towards the northern and in the southern hemisphere. And you know what? The northern and southern hemisphere is filled with gases. There are some gases when it will be exposed with charged particles, solar particles, it will produce certain kind of light. So which means uh, these are electrically charged particles. So these electrically charged particles, when it uh, hits the different gases such as neon gas, argon, and some of these gases present already in our atmosphere in the southern, in the northern hemisphere, will react and will create certain display of light, and that display of light is what we call aurora. Okay. If you would like to read more about aurora, you can just research more about aurora. You can even look at some videos about aurora, video tutorials in YouTube about aurora. But basically, this aurora is a certain atmospheric phenomenon which can be experienced on Earth. Another uh, basic phenomenon that we can experience on Earth is the greenhouse effect or the greenhouse warming. So I think maybe you're familiar already with greenhouse effect. Greenhouse is something like a glass cover. If you have here a garden and if you cover it with a glass, the the sunlight, the heat will be trapped within, and it could actually be useful to the plants. And this is also the same thing with what happens to the earth. Let me show to you a picture over here. So this is actually what we call the natural greenhouse effect. So heat from the sun will eventually move towards and it passes by the Earth's atmosphere, but as it hits the surface, some of this heat will be re-radiated back into the atmosphere. But when it supposedly moves outward towards the outer space, it cannot anymore move out because of the barrier. The barrier here is actually our atmosphere, so it will just be bouncing back towards the surface, and as it reflected again towards the atmosphere, there will be no moving out of the Earth's heat. So there will be re-emissions of heat in the surface, and heat will be trapped. That's the this effect. When this happens, producing lots of heat, huge amount of heat in the surface of the Earth, is what we call greenhouse effect. So that's also one thing that sometimes greenhouse effect would be useful, but it could sometimes be harmful. The natural greenhouse effect is good for us because it traps heat, because some of the living things on the surface of the earth are warm-blooded, so it could actually be useful to us, no, to keep ourselves from cold. But uh, because of the tremendous amount of greenhouse gases can actually trap heat. Human enhanced greenhouse effect is actually harmful. So that is why, such as this methane, we have nitrous oxide, these particular gases, if these are uh, produced in the atmosphere, it could be uh, disastrous. It could cause harm to us. So that's the greenhouse effect. Atmospheric electricity, the electrical discharge in the atmosphere. What when you say atmospheric electricity, it has to do with lightning, volt of lightning, huge amount of lightning, and because of the presence of the clouds, maybe in our first quarter, I think in the third quarter, in the second quarter, we already have discussed about lightning. The reason why there is lightning because of the clouds. When there is turbulence of air within the clouds, or water vapor within the clouds, some of the charged particles will separate itself from each other. Positive charge will be moving upward and negative charge will be on the bottom. And since the earth is positively charged, So it could actually create a spark, and it will be generated in a form of atmospheric electricity. We call that sometimes as lightning, thunder and lightning, because they go together. Halo is also another atmospheric phenomenon, a circle of light around the sun or moon. Maybe you have seen that already, but if this is the sun and you are watching the sun, the moon, for example, on the Earth's surface, and you have here a very thin gas, eventually the light will be reflected to the surface of this thin gas, and eventually it will form like a rainbow. So various colors will be reflected to that in a form of, because there are water vapor in the Earth's atmosphere. So if there is a thin clouds, such as cirrus clouds in the atmosphere, halo will be generated. Let me show to you a picture of a halo. This is a different halo. I don't have a picture here of a halo, so maybe later I'm going to show that to you. You will be the one to look for a picture of a halo. Meteor shower and meteor stream. I think I have already discussed this with you. So because of the presence of the atmosphere, some of these meteoroids will hit the surface of our atmosphere, and it will generate streak of light. We call it a meteor. Tagan sila, meteor shower ang tawag. Then, the famous sunrise. When sun rises, the atmospheric phenomenon, upon daily appearance of the sun. And opposite to that is sunset. Afterglow, a glow sometimes seen in the sky after sunset. So afterglow, during night sky, it seems that you can still see the glow of the sun from above the Earth's surface. So that is what we call afterglow. Atmospheric condition, weather conditions. So rainings or something like that. So kanang mga bagyo or mga so widespread air disturbance, we call it weather conditions. Dew, water that has condensed on cool surface overnight from water vapor in the air. Air current, current of air, wind moving, so that is actually on a certain region on the atmosphere. Lightning, electric discharge from clouds to clouds or from clouds to the surface of the earth, so that's actually lightning. Warm front, cold front, the polar front. In fact, we have Amihan and Habagat. These are actually experienced. These are natural atmospheric phenomenon wherein due to the movement of air and wind in the surface of the earth because of the distributions of heat, no? Irregularities in the distribution of heat. And of course, another atmospheric phenomenon which is actually magnificent enough is actually the presence of a rainbow. And I think you're very familiar with the rainbow. So solar energy is actually very important because it is the very reason why we have lots of atmospheric phenomena. I have already discussed this greenhouse effect with you. So sometimes greenhouse effect is sometimes considered as uh, infrared. No, the reason the radiation from the sun, which cannot be felt by our which cannot be we cannot see it by our naked eyes, but we can feel it by our skin. That's actually what we call infrared radiation or heat radiation. So note that trace gas is a gas which makes up less than 1% by the volume of the Earth's atmosphere. It includes except nitrogen and oxygen because that's the most abundant gases in our atmosphere. So we have argon, water vapor, and some other gases. And here are some of the primary and natural greenhouse gases of the Earth. These are natural greenhouse gases. This is generated naturally by living things and the Earth itself. Carbon dioxide is produced by the animals, and methane gas produced by bacteria. No, and it generates the ozone when three atoms of oxygen uh, bond with each other to form the ozone layer. And we have the nitrous oxide, naturally present in the atmosphere as part of the Earth's nitrogen cycle. These four basic type of gases, are actually natural greenhouse gases. So, if these four basic greenhouse gases is present, we are secure and we are protected. But sometimes there are many man-made greenhouse gases which could actually cause harm. So what we have learned a while ago, these are actually human-enhanced greenhouse effect, which is actually harmful. It could trigger melting of the ice caps in the polar region, and in, increasing the amount of the volume of water in our oceans, and the rising of oceans, making no contributing to huge atmospheric phenomenon. So it could trigger into very wild typhoon, for example, tornado, that could be damaging to the earth and to human establishments. So what are the main man-made greenhouse gases? First thing is carbon dioxide, methane, nitrous oxide, kaning pinaka kuan kaning fluorinated gases or the F gases. This is very harmful. F gases are generated due to our different industrial activities such as the use of cars, refrigerants. So we have a common refrigerant part of the cooling system of our air conditioning unit and some of our cars, the chlorofluorocarbon, the CFC. Sometimes it's also there on sprays, no. So we also have HFCs and PFCs, hydrofluorocarbons and perfluorocarbons, and even SF6 or hexafluoride, and we have NF3, nitrogen trifluoride. These are all F gases which can cause damage into our ozone layer. And we could get this from refrigerators, refrigerants, and making foams and plastics. And that is why plastics is very dangerous to be burned, because some of these chlorofluorocarbons, CFCs, are there present in the plastics, and when you burn it, it will be brought to the atmosphere as contributor of the rising number of human enhanced greenhouse effect. It could trigger disaster. So, okay lang tong normal nga greenhouse effect because it is useful to us. That is why, to prevent the production of more carbon dioxide, we need to plant more trees. And we could generate more amount of oxygen to prevent. What is something that must be prevented here is the appearance of global warming. Because greenhouse gases could trap heat on the Earth's surface, and it could trigger into global warming. What is the effect of global warming is that when tremendous amount of heat will be here in the presence of the Earth, more and more wind will be generated. So powerful wind could be generated in the form of typhoon and sometimes tornado, and it could damage properties of different human beings on Earth. And greenhouse effect is very no, global warming is very dangerous because it could trigger a lot of no, chain reaction. Various atmospheric phenomena will be affected out of this. So these are our lesson on the Earth's atmosphere. So if you have some queries, some clarifications, you can rewind the video. You can look back and try to pause and read the handout. So one thing that I would like you to do is to get one whole sheet of paper and write it down. What do you think would be our move as human being to prevent global warming from happening? Based from the lessons that we have learned, based from all of this human intervention on the production of CFCs, the F gases, because humans are the very source of these F gases, because of our industrial use of the F gases, it could trigger into global warming. So warming. So what should be done? So I want you to write that down on a one whole sheet of paper. Write as much as possible. You can write 20 possible ways to prevent global warming. So anything that you can think of just to prevent global warming. So write it down, submit it to your science teacher for an additional points. So that's all for this video. Thank you very much for watching. This is your friendly science teacher from Zamboanga del Sur National High School, Mr. Matthew Tisa Basales, saying stay cool and enjoy learning science.